Okay, so we're going to be doing some work with exponential decay. So there have been lots of questions about this, and so what I did was I came up with some questions that are similar to the ones that you've been working on, except they're not really in word problem form. It's just in a table, but it's basically the same idea. There's only a few things they could be asking you to do. All right, so we're going to be looking at these, made up isotopes or these made up elements or whatever you want to call them, and we're going to be working with them, and you're going to see that all of these exponential decay ones are basically the same idea. So if you take a look, the first one says mathonium has a half-life of 1,620 years. So in other words, it takes 1,620 years for half of the matter to have decayed. So whatever you start with, it doesn't matter how much. If I started with, this one says 10 grams, in 1,620 years, only 5 grams would remain. If we started with 200, only 100 grams would remain after 1,620 years, okay? So what formula are we going to use if we're going to try to fill in these missing pieces? And what you'll see is in the word problems, all the same pieces are missing. They either tell you what the half-life is, what the initial quantity is, the amount after so many years, or they might tell you what the rate is. That's the other thing they might tell you. Now, none of these tell us the rate, so we're going to have to figure that out first, and then we'll be able to fill in all of these things. So it could even be that some of the problems that you have are actually, one step less. But let's take a look. Okay, now all of them are going to use our exponential growth formula. So let me write it this way because it looks better. So this is the formula we're going to be using, okay? And we said before that E is just a constant. He's sort of like pi. He's just some irrational number. Later on, if you study math more, you'll find out where he comes from. He's a very famous number. And we're going to use him in all our exponential growth and decay questions. And he's actually called the natural base or the natural log when he's this one. Remember this one. This is e to the x is equal, e to the y is equal to x. This is just log base e. So we're going to use this log base e to solve these problems, okay? Some of them. Some of them we won't even need the log, but some of them we will. So let's take a look. So the first one, they give us the half-life and they give us the quantity at the beginning. So remember, P is the quantity at the beginning, so I'm going to plug that in because that's what I know. So we'll do the mathonium first. All right. We don't know the amount after, so many years. So that's just going to remain B. We do know this one. It's 10 grams. This one, well, I'm not going to use the G because that's just going to confuse everybody. So I'm going to just E. We don't know the rate, and we know that the time. In this particular one, they tell us the time, but let's fill it in after. Okay, so far, what we've filled in is the initial quantity. All right, now if it's half-life in years, and this is 10, that means if I were to put 1620 in here for my time, how much material would be left over here? If it's half-life, it means that this will be a 5 because that's when half the material will be left. Now, here's the thing is, whenever we're solving these, if it's half-life, what's going to end up happening is this number over here is always going to end up being 1/2. Because whatever you start with, like I said, if it was 200, this would have been 100. 200 divided by 100 is 1/2. So no matter what it is, if you're talking about the half-life, if they give you the number of years for half-life, then you want this number, you can make this number 1 and this number 1/2. You could make this number 200 and this number 100. Just pick a number that's half as big and put it over here. And you're always going to simplify to this expression. Okay? Now to solve this one, we are going to use this guy. What we're going to do is we're going to log both sides, but I'm actually going to natural log both sides. And the reason I'm going to do that is because this thing is something I know what it is, all right? So I'm going to use my exponent rules, and I'm going to throw that one out front not my exponent rules. Well, I guess exponent rules, but I meant log rules. So my log rules say I can kick this guy out front, right? And now this thing, if this says, what do I raise e to get e? Because remember, ln equals log base e. So this says log base e of e. So what do I raise e to get e? Obviously, that's going to be a 1. So ln e is just a 1. So this whole thing simplifies to 1. So it'll be 1620r times 1. And of course, once it's a 1 and I'm multiplying by him, I don't even really need to write him anymore, right? So this says ln 1/2 is equal to 1620r. And now I want to solve for the rate. And why am I solving for the rate? Because I need the rate in my equation to be able to do any of the work. And so this thing, they didn't tell me what the rate was, but they gave me enough information to figure out the rate. Okay? So now I'm going to divide both sides by 620. And now I'm going to go 1620. And now I'm going to go to my calculator because I don't know those numbers. So here I am with my calculator. I'm going to use the natural log, so that's this ln button. So ln of 1/2, and I can type it as 1 divided by 2, or I can type it as 0.5 or whatever you want, but just make sure you close the parentheses. And then you want to divide that by 1620. So divided by 1620, and that gives you a negative 4.27. So this is a kind of a, a weird number because this is now our rate. So this is the decimal form of our rate. So it actually means like 427, well, I guess like 28%, 428%. But this is the number we're going to use in our equation, okay? Because we use the decimal form of that equation, of that number in our equation. So let's go back to this one. So here we are back up here. We already knew the 10, and now we know what R is. So I'm going to plug in the stuff I know. So we have B is equal to 10e to the negative 4.2786. And again, for me, what I'm going to do is I'm going to hit this store button and call it alpha. You can call it whatever you want. If you want to call it R, there's an R here so that I know that it's the rate. I'll call it alpha R. Now, all I have to do is type R in my calculator, and I don't have to type this number anymore. And I don't have to round it. I get to use all those decimal places. Okay, so now this is my equation with the t, so the time. Now, if I go back to the original question, that actually isn't what I wanted to know. They didn't ask me the rate. They asked me, how much will I have after 1,000 years? So let's just ask ourselves for 1 second. Is that going to be more or less than 5? So we said, the half-life is 1620, and that will leave us with 5 grams of material left, right? This is only 1,000 years, and this is 1620. So to get down to 5, it took us 1620. So this should be a little more than 5, right? This should be more than 5, between 5 and 10. So I just do that so that I make sure that, I have some idea what my answer should be so that I know if I got it right, okay? So let's take a look at this guy. So how are we going to solve this one? After 1,000 years, all I have to do now is substitute in for the t. What am I going to put in for the t? I'm going to put in 1,000 years, of course, right? So we're going to have, my amount is going to be equal to 10 e to the negative 4.2786 times 1,000. Okay, so it's hard to see because I squeezed it in there, but there he is. Okay, just because the question asked me after 1,000 years, that's why I put that in there. All right, so now we get, all I have to do is type this mess into my calculator. So how am I going to do that? Well, fortunately, I made it a little bit easier for myself by storing that number as R, so I highly suggest you do that. So what am I going to type in? I'm going to type in 10 E, and now my calculator already puts it in because I picked this little guy here, where it is ln. It's hard to see it in this one, but above it is e to the x. So you have to hit your second button. And I'm going to do negative, and I'm going to use the negative, not the minus sign. Well, actually, I'm not even going to do that. I'm going to use r because I have r stored in there. So I'm just going to type in r. I don't have to type it in. I'm going to save myself some time. So I'm going to do alpha r times 1,000 is the number of years. And so that represents this little expression right here. Okay? And now when I hit enter, it tells me that it's 6.51. And then the only thing left to do, usually they tell you where to round it. If they don't tell you, I round it to, I like to see at least 4 decimal places here. And I put a 5th one just because I always think more accurate is better. So this is how much will be left after 1,000 years. And that makes sense with our original question because we said in 1620 it was going to be a 5. So we expected a number bigger than 5 but less than 10 because we started with 10. So there you go. That's how you would do this first one, where they tell you the half-life and the original amount, and you have to find out what it is after a certain number of years. Okay, I'll do the other ones in separate videos so you can watch as many as you want or as few as you need.